Section 10-4 is on minimal path problems. The objective of this section is given a situation in which something goes from one place to another through two different media at different rates. You want to find the path that minimizes the total cost or the total time or the total weight, depending on the problem that's presented to you. If you recall back in Chapter 8, we saw some problems where we were minimizing, maximizing quantities. We are minimizing the cost or maximizing the area or the volume. And those problems involved sketching a picture of the situation, finding an equation for what you want to minimize or maximize, finding a domain, and then using a derivative and finding where that derivative is either zero or undefined to help you find the solution to the problem. These problems are going to follow a very similar path that those ones did. So let's take a look at an example. Look at example 1 there in 514. It says, suppose that you are 200 yards from the beach and in the minimum possible time you want to get to the place where you left your towel. You walk on the beach at 110 yards per minute, but can swim only 70 yards per minute. Let x be the distance from the closest point on the beach to the point where you make landfall. What value of x minimizes your total time if your towel is, and they give you two parts to this question. Part A is the towel is 600 yards from the closest point. And for part B, what if it's 100 yards from the closest point? All right, so let's take a look at how to solve this problem. We're going to start out, like I said, with a sketch, just like we did in Chapter 8. So let's draw a sketch of this situation here. So let's say that this is our beach down here. This will be the beach at the bottom. And we'll say that this is you out in the water right here. And we'll say that this is your towel down here on the beach. And so you're going to swim from where you are in the water. And you're going to hit the beach somewhere here, we'll say. And then you're going to proceed walking from that point to your towel. All right, so that's the path that you're going to take to get from point A, where you are, to point B, where your towel's at. And they told us a couple of other pieces of information. They told you that you are initially 200 yards from the beach. So let's mark that as well, that this distance right here is 200 yards. And they also told you to define x, let x be the distance from the closest point on the beach to the point where you make landfall. So they're saying that this horizontal distance right here is what they're calling x. And for part A in this problem, they said, okay, let's suppose that this distance from where you are to where your towel is 600 yards. All right, so if that's 600 yards, then this distance that you're going to walk must be 600 minus x, because that horizontal distance that they gave you was x. The sum of those two has to give you 600. All right, and the other thing that we should write down is the rate at which you can swim and walk here. It says that you can walk along the beach at 110 yards per minute, so I can walk in this direction at 110 yards per minute. And I can swim in this direction towards the beach at 70 yards per minute. Okay, so then in other words, the question here is, what's the path that I should take to get to the towel to minimize my time? So let's write that down, that we're trying to minimize time here for both the parts of this one. We're minimizing time. So I need an equation for time, and I guess I got to go back and refresh my memory here as far as how time is related to this distance I've got to swim, as well as what rate that I'm going to swim at, as well as the portion I have to walk at. So I know that distance is equal to rate times time. So in other words, time is equal to the distance divided by my rate. So for this problem, that's the way I'm going to calculate that. The other way to look at this, you can sometimes tell just by looking at the units here in this problem, that my distance, for example, is measured in yards. And my rate is in yards per minute. So if you simplify this, the yards here will cancel out. You'll actually be left with 1 divided by 1 over minutes is what your units turn out to be, which when you simplify that, 1 over minutes just turns out to be minutes. So you can see how this simplifies down to just minutes here when I take and divide these two. Sometimes you have a formula like this that I know distance is equal to rate times time. Other times you might have to look at the units in your problem to help you figure out how I set the problem up. Do I divide these values? Do I multiply them? What do I got to do in order to get the result I'm looking for? So for this one, we're going to divide distance by rate to get time. So we've got two different times to account for. We'll call this big T here, I guess, for time. I gotta swim to the beach, so I've got to figure out how far I've got to swim first of all, and then secondly, how fast I can swim at that. Take the ratio of those will give me my time. So they told you that the distance you are from the beach was 200 yards, and we're going to hit land at position X. So there's two sides of this right triangle sitting right here, and I can find the hypotenuse using Pythagorean theorem. This is the square root of x squared plus 200 squared. So that's the distance I'm going to travel in the water. So it's the square root of x squared plus 200 squared divided by my rate, and the rate they told us was 70 yards per minute that I could swim at. So the distance divided by my rate there gives me how much time I'm going to be in the water. And we'll add that to the distance that we're going to go along the beach, which was 600 minus x, divided by our rate, which was the 110. Again, if you draw the picture there, that really helps out with setting this whole thing up, first of all, but secondly, it has all the information you need there in order to do that. So this is my equation for how much time it's going to take me. I should get two things here, first of all. Get it in a form that I can easily take the derivative of. And then secondly, I need to find the domain for this thing. So let's rewrite this. I'm going to put the 1 over 70 out front, kind of as a constant out front. And I'm going to write this as x squared plus 200 squared to the 1/2 power. And then I'll write it as 1 over 110 times the 600 minus x for the second part there. All right, now I just need a domain for this thing. And again, if you look at your sketch here, it kind of shows you what makes sense. You just got to think about x and what's the smallest you could make x and what's the largest you can make x. Well, if I swam directly towards shore, so that means my point of landfall would be right here. That would be x is 0. Versus if I swam all the way right to my towel, that would be right here, and that would mean that x is going to be 600 in that case because the towel is 600 yards away. So it looks like my domain for this problem is x is going to be from 0 to 600. Again, just looking at the situation, and again, the sketch there definitely helps you get that. All right, so now that I've got a function that I want to minimize, and I've got a domain for that function, I am all set to take a derivative of this thing. So let's find t prime. T prime is equal to the 1 over 70 times, so let me put the 1/2 out front there first, times 1/2 of the quantity. This is a composite function, so follow chain rule as you take this derivative. X squared plus 200 squared to the negative 1/2 times the derivative of the inside is just 2x. And then we'll add that to the derivative of the second part of this function is 1 over 110 times the derivative of the 600 minus x. Derivative of 600, of course, is 0. Derivative of a negative x is a negative 1. And you want to find where this is 0 or undefined, just like we did for all those problems in Chapter 8. All right, so let's find out what the solution or solutions to this equation are. And I'm going to cancel out a couple of things here and rewrite this slightly. I've got a 2 and a 1/2. Those will clearly cancel out, so I'll cancel those out right away. And I'm going to rewrite this as x divided by 70 times the square root of x squared plus 200 squared. That's what the negative 1/2 exponent means. You can move that to the denominator. And then it's minus 1 over 110 is equal to 0 or undefined. All right, so as far as where this thing's undefined, we'd only be undefined if we were dividing by 0 in this case. But this first quantity here, that square root that's in the denominator, you've got x squared, which is always going to be greater than or equal to 0, and you got 200 squared, which is always obviously positive there. So this is a positive amount in the denominator of that first fraction. You're never going to be undefined. It's just finding where the 0 is at. So to find out where that 0 is at, you could solve this algebraically. I'm going to use my calculator to solve this thing, though. If you're going to solve it algebraically, you'd move the 1 over 110 to the other side, cross multiply, and then square both sides to get rid of the square root, and so forth. There's a number of steps algebraically you'd have to do to get that solution, but you certainly could do it. I'm going to use the solver feature on my calculator to help me solve this. You could graph this thing and find where the 0 is at. There's several ways that you could do it, but I'm going to just use solver. So solver, and let me get rid of that old equation there and just type in the equation here. You got to be careful, obviously, that you get this all typed in correctly, but it's x divided by 70 times the square root of x squared plus the 200 squared, and then minus the 1 over 110. Now remember, this is automatically set equal to 0. If your equation's not set equal to 0, just move everything to one side so you have 0 on one side, and you can use solver. And I'll go down here. It's going to ask me for a guess. I don't know where the best place is. I'm going to just guess somewhere in the middle. That's probably not going to be the middle, but I'll guess 300 is my guess for the solution for this thing. And then you got to press alpha and then enter to solve this thing. If you look above your enter key, solve is in the same color as alpha. So that's what you've got to do. And you get 164.992. 164.992. So x is equal to 164.992. And of course, we've got to check our endpoints as well. Our domain there was 0 to 600, so we'll check those as well. Those come in from our endpoint. So we'll find out which one of these three gives us the minimum value. So we're going to take our time function. We're going to evaluate it at 0. We're going to evaluate it at 164.992. And we're going to evaluate at 600. And whichever one of these gives us the smallest time, that's the one we're going to go with. So let me store this value actually that I have. The value of x is the value that I just got, and I want to save that into a different variable just so that I don't lose that number. So, oops, I was going to bring up the calculator so you could see that. So the value of x again was the calculation we just did, and I'm just storing that into a here in this case. And let's put in y1 as our time function. So our time function again was the square root of x squared plus 200 squared. This is not the derivative. This is the original function divided by the rate at which we could swim, which was 70 yards per minute, plus the 600 minus x, and divide that by the 110. So there's our time function. And we're just going to use, I'm going to use the table here to set this up, and we'll put it into ask mode. And we will just punch in those three values that we're looking for. So 0, and then the value that I just stored into A, and then 600. And again, we're looking for the smallest one. Well, it looks like the smallest one is at 164.992. So let's put down those values that we had there. I should write all of them down. So it's 8.312 is the first one. 8.312. And the second one was 7.659, 7.659, and the last one at 600 was 9.035. Okay, and these were all measured in, the rate was in yards per minute, so these are all in minutes. So this guy right here is our minimum. Again, make sure that you indicate which one is your minimum time there. Okay, the MIN there again is not for minimum, it's for minutes, is what we're marking there. So 7.659 minutes. So the key value that they're looking for was what value of x, and the value of x is this guy right here. Okay. Now if you look, that's part A. Part B now says do the same problem again, but now use 100 yards as your location for the towel. So let's just go back and look at the work that we've done already and compare that with how that will change if we change the distance there. So first of all, the 600 yards, we can clearly see that this is going to change to 100 yards instead of 600, which means that this here is going to be 100 minus x instead of 600 minus x. And that changes our equation then over here. This becomes, instead of 600 minus x, this would be 100 minus x. And of course it changes in the next line here. This would be a 100. Our domain, of course, would change because now we're not going to walk 600 yards, obviously, because of the fact that the towel is only 100 yards away. And notice what happens with the derivative. The 600 minus x, when you take the derivative of it, that's right here. The 600 disappears. So in other words, the derivative is still the same. In other words, the solution that you would get from this derivative would still be the same. And of course, again, this changes. Instead of it being an endpoint of 600, it'd be 100, which actually means that the 164.992 is outside of my domain. So the problem is exactly the same. The only thing that's different at the end is which one of these solutions that I pick. So in part A, this was part A solution. We had to pick from those values. For part B, the only thing I need to change here is check the endpoint at 100. I already know that 164.992 is outside of the domain. So I know T of 0 is equal to 8.312. I just need to find out what T at 100 would equal. Again, my endpoint here changes. Instead of this being 600, I got to use 100. So let's check that value out and see between 0 and 100 which one gives us the smaller value. So at 100 we get 7.340, 7.740. 7.740. And so the minimum in that case turns out to be at 100 right here. And this is in, oops, I should have put the units on there. Let me do that again. This is in minutes. So this is our minimum time. So again, to answer their question, the question is what's the value of x? Turns out that x is going to be 100 in that case, so you're going to head directly towards the towel. You're going to swim all the way there. It's going to be the fastest way to get there. So those are the types of problems that we're going to see in this section.